Hello, my name is Vladimir. I am a core team member of Vitest and a team member of Vit. I joined the Vit team before it was released in 2021, so I've been involved with the project for a long time now. And I joined Vit team last year, almost right here, behind the curtains. They gave me like the t-shirt and everything. But enough about me. Today I'm going to talk about Vitest, how we do module mocking, and how it's different from Jest. I will be talking only about mocking modules. In some examples you might see like VFN, like in this slide with the resolve. If you don't know what they do, the easiest way to understand is they return a function, and you can control the behavior of that function from the outside. For example, call mock return value, just also like in this slide. Similarly to function mocking, module mocking is about changing the behavior of the whole module, of a JavaScript module. It can reference the original module, or it can do something else entirely. When mocking a module, you want to make sure that other modules in your source code don't really depend on the mocking behavior, because otherwise it will be completely pointless. On this slide, you can see a general example of a module mock. It replaces src resolve module with another object that returns resolve method. Note that the resolve in the first test is also a function mock, and you can call mock return value. So the resolve that you import from a module on the top is an actual mocked function, and you can already call the mock return value right away without storing the mocked resolve method outside of the mock factory. But you can also rewrite it if you need better TypeScript support. Here we have vhoisted function that just gives the hint to the transformer that this statement should be executed before all the mock registration and all the imports kicked in. Vhoisted and vmock are transformed the same way, so the order of declaration matters. In this talk, I'll be talking only about vmock function. You can apply the same principles for but you can apply the same principles for vhoisted. Now let me try to explain how it works step by step. To understand how module mocking in Vitest works, we first need to understand how modules are transformed and loaded by Vitest. We use vitnode package under the hood, which relies on VitSSR transformations. This gives us full control over what modules are returned from import functions, and this also helps us with CGS and ESM interpolation issues that are very prevalent in Jest ecosystem. As you can see here, all static imports are replaced with dynamic SSR import functions. These functions already have resolved IDs, and this is where the next transformation will happen. So when this function is called, the same transformation will happen unless the module is externalized. Vitest will externalize its own import, Vitest, which means it will be loaded by native Node.js import function and will not be transformed like this slide here. But src resolve will be transformed into a similar file that will be loaded when the import function is executed. You can also see that all named experts were replaced with module getters, and I will explain later why. Basically, this is what happens under the hood with all source code and inlined modules. If you ever had an error that recommended you to inline a model, this is why. So instead of using Node.js module loader, for example, which is still a bit experimental for our test, we will use this vitnode package. This has several advantages. As I said before, it allows us to control the whole module system and not rely on the standard in case we need to bend it for better developer experience, like emulate how bundler would behave or allow overriding module experts. For example, you can use vspy on a module expert and override this, but this wouldn't work in a standard ESM environment like a browser. Having our own module system allows us to have no memory leak when voucher triggers the test rerun. If we were to use native module loader, it would cause a memory leak because ESM doesn't have a mechanism to clear its own cache. Using this API also allows us to reuse already existing Vit's built-in runtime APIs used for SSR, which makes it easier to test Vit-specific code like SSR code. Okay, now this is the code that you would usually see when mocking a module. This will not work without any file transformations because of a very easy mistake that we made right here, because vmock is executed too late. Imports are executed before vmock is ever called, but how would we fix it? Let's try to move the vmock before the import. This will also not work because all static imports like this, even if they are defined after a function call, they are executed, they are still hoisted to the top of the file and executed before any code is declared here. One of the possible solutions can be using a dynamic import, which are not hoisted. So let's transform all static imports into dynamic ones. Okay, like this. Do you think this will work? Raise a hand if you think this will work. Well, kind of. If we run this code, assuming vmock magically returns the mocked object, it doesn't fail, so this code actually works, assuming that vmock registers a module and stuff. But what if our original file is actually imported by another source file and not the test file? So right here we import src resolve, right? And we also mock src resolve, which quite kind of dumb to test like this. This is more of a usual example. Here you can see that resolve is still mocked, but it's actually imported by a wrapper. So this is a wrapper file that imports resolve. Do you think this code will work? Raise your hand if you think this code will work. Well, it will work. But not every time. There is this weird thing like this. ESM allows you to overwrite your exports if they are declared with let, or I guess function also will allow overriding. So this is a correct syntax. I hope no one writes code like this, unless it's like a function, unless it's a variable that you overwrite inside of another function. This is a feature of ESM called live binding. You can reassign the value of exported variable, and when accessing it via a static named import, you always get the latest value. Unfortunately for us here, we lost the value. We lost the value here because we imported via a dynamic import. So when we do this, we actually destructure a module object, and it takes the value that was there at the time, so this one, and it never overwrites. So when this kicks in, this is not, this is not overridden. But how do we fix this? Well, Vitnode comes to help us. Earlier I explained how Vitnode processes files before Vitest consumes them, and you might notice a similar pattern here. Basically, we are replacing all references to the module with a getter, like here. So we declare a module, and we append this module name to every variable that it references. So this allows us to reuse a similar mechanism to mock modules in the browser, which is not yet supported, but should be soon. Fortunately, we only need to do this for files that have vmock in them, so this doesn't affect performance in a huge way. Okay, now we made sure that vmock is called before all the static imports. So in your source file, you would have import here as a static import. This is already a transformed file. But how do we tell the runtime to use the mocked module? There are several ways you can mock a module in Vitest. In all the previous examples, we used like auto-mocking signature, like here, we just say mock and let it do its magic. Basically, when you don't define a factory, like here, Vitest will import the module and mock all the exports, replacing them with a spy. It always returns undefined by default. Here's a rough example of what's happening. What's happening? This is actually not the code that's running, but it's like a similar example what would happen under the hood. Since we have access to the experts object, we can just override all the methods, and we know them at runtime. However, if you have a mocks folder like this, and it has the file with the same name, so so we have src resolve, right? And we have src mocks resolve. Vitest will automatically pick up this file instead of the original file, and it will not perform auto mocking. Another example is using the factory. Instead of relying on mocks folder or auto mocking behavior, you can define your own factory. The first argument is always the function that loads the original module that you can run if needed. So this is the first argument. Thank you, Anthony, for implementing this feature. By the way, when the mockit module is imported, Vitest will execute this factory. So this factory is not executed right away. Vitest will wait when the import happens to execute this function instead of importing the actual module. Okay, so now we know how to register the mockit module, but how does the runtime know that the module was mocked? Let's look at this simplified mocker implementation. This is actual parts of the code from Vitest mocker from the source code. When vmock is called, it pushes a new value to pending IDs, right here, right? So basically, we specify that we want to mock some kind of a module, but we don't know yet what its ID is, because you have like alias, use resolve alias, you resolve conditions and so on, or even override with a plugin. We don't know yet how it should be resolved. Then we need to resolve it. But when does this happen? Let's say mocker exposes this intercept function that returns an experts object. Somehow, we need to make the runtime aware that it should wait for the mocker to resolve before importing the module. Otherwise, there will be a race condition. In this interceptor, we make sure that all mocks are resolved in ensure mockit module, so function. We have this function, we go over every ID, and we make sure that it's resolved, and we like store it in some kind of a cache. It also resolves the mocks path if there is one, and just stores information about the factory for the future use. After ensuring that all modules are resolved, we can check if the current URL should be mocked, right? Is mocked URL. Then if it is, then we just return the mock. The only thing left is to call this function. So now another small disclaimer. Well, first small disclaimer. At the moment, Vitest uses VitNode under the hood, but in the future, its programmatic API will be softly deprecated in favor of the new Vit Runtime API that allows you to run Vit-compatible code in any JavaScript environment. If you've been using Vitest VitNode CLI, you should be fine since only internals will change. I will be using the Vit Runtime API here as a demonstration, but if you would look into the current source code, you'd see the old VitNode implementation. If you want to know more about our new experimental API, head here and it has some links to the feedback. Please give us feedback. It's mostly for framework authors, but any feedback is welcome. The new Runtime API allows overriding the behavior of the runner. So you can define your own function here. You have a Vitest module runner. And return an experts object. We can just call there is a run Vit module, which overrides which I think here it just uses the standard is module runtime, overrides run Vit module where we call this intercept request method. And if something was returned, so then we know that the module was mocked, we can just override its experts. This is basically it. To make Vitest module mocker work, we transform files to turn all static imports into dynamic ones, replaced all the named experts with module getters, move vmock to top of the file to register the mocks before imports are executed. We intercept all requests in imports to ensure all mocks are resolved before we can return a mock. And we check every import if the model should be mocked. If it is, then we just mock it. Now that we know how Vitest mocker works, let's look into some common mistakes and edge cases that people run into. Vitest tries to be helpful if you've made a mistake when mocking a module. Vitest will throw an error with an example on how to fix it if you don't return a certain named expert, but you try to access it, like in the tweet here. Vitest will throw an error if you don't return an object. It is expected that the factory returns a compatible ES module, I guess, and it can only be an object as defined by the spec. This was a deliberate decision that caused some issues with Jest migration, as it was causing CommonJS, as Jest uses CommonJS by default, which allows anything as a module expert because it's just a require function. Vitest will throw an error if you try to access a variable from the outer scope, explaining that the top-level variables are not accessible. As you already saw in the previous slides, the parse variable was not defined yet, since this is hoisted before the import, and the import is turned into a dynamic import. And Vitest will ignore any properties that don't exist on the original module, because to make sure that it doesn't exist, we need to import the original module, which will defeat the purpose of mocking a module. The most common issue people have with the module mocking is mocking module's inner function. A lot of mocking. In this example, we have a foobar module. This is a foobar module. It exports foo and foobar methods, our favorite names. Here's foo and foobar. And foobar method calls inside itself the method foo. We want to mock only part of the module. I can move it like this. We only want to mock part of the module, only the foo function. We can try to define a factory. Import the original module, and return the new foo function. So this will have original foo and foobar methods, but then we override method foo here. But what happens? Well, looks kind of all right. It did work in Jest if you use TypeScript. But what happens in Vitest? Here, what will it output? Well, a bug, I guess. It doesn't work like expected. Well, this doesn't work like expected. What's actually happening here is perfectly expected behavior. So this will, we would expect that this would return mocked bar, and this would return mocked, but it actually returns the original foo bar. When you return an object here, you define a module exports namespace, basically. This is a ES module. It is used only by other modules that import this module. It's not referenced anywhere inside of this file. So inside of this file, we say just foo. We don't try to reference this like exports foo or anything like that. It's not referenced anywhere like that, as you can see in the example. The foo function is referenced directly. It's not attached to any object. It's named foo. And you call it here as foo. This code actually also doesn't work with Jest unless you use TypeScript with TS Node. Like if you use Jest with TypeScript and SWC, for example, it will also not work. Because TS Node transforms this into this. So here. So it transforms the expert function foo into experts.foo equals function foo, and experts foo bar equals function foo bar. So, and then, which is the most important part, it references, instead of referencing the foo directly, it references the experts object foo, allowing you to override this method that will be called here. How do we fix this in Vitest? One solution is to create a separate file to keep the dependency in. Since it's a separate module, the mocker correctly intercepts the object and replaces it with a mock. We could theoretically transform all experts in a similar fashion, like TS Node does, but this goes against the ESM spec, like heavily against the ESM spec. So I personally think that this solution is better in the long term to keep it more compatible with how JavaScript works. As the last use case that I wanted to talk about is virtual modules. So Jest supports mocking virtual module with vmock, name, factory, and virtual true. But Vite has built-in virtual module support via a plugin. But this leads to unexpected behavior when we have this, but we import it here. Yeah, right. So we have the mock here, and then we import it here. This will fail at transformation when transforming this file because Vite should know about how to resolve this import. So it sees unknown import, it just fails. To make virtual modules work, you need to define them in the config like this. If import is equal to the virtual module, you can return, so you let the Vite know how these modules work. This is enough for Vite to be satisfied and not fail. And at the runtime, we would never call, usually you would expect here like a load and transform to load the contents of the file. But since we mocked it here, we will never ask Vite to transform this file for us. It is mocked with the factory. This is all that I wanted to talk about today. This concludes my talk. All of the examples that I showed you should be in the Vitest documentation under the module mocking guide if you ever need a reminder. And I guess thank you for listening.